All right, so we are on surface areas of circular solids, and this is in 12.3. You only have one objective, and that is to find the surface areas of circular solids. So that would be sphere, cone, and cylinder, because they all have a circle as either their bases, or in the case of a sphere, it's basically made up of circles. Okay, so let's start with cylinder. A cylinder is similar to a prism in that it has two parallel congruent bases. Think of a can of pop. So like if it had a label, and if you peel that label off, that would be the lateral surface area. It'd look like a rectangle. Kind of like that. If you took the top and bottom off and then unraveled the label, that's what it would look like. Okay, so that is the height right there. The length, or the base, whichever you want to call it, is the circumference. All right? So that brings us to Theorem 113, which states that the lateral area of a cylinder is equal to the product of the height and the circumference of the base. Okay, so we can just say circumference times the height if you're given that, or if you're not and you're just given the radius, you can do 2 pi r times h, where c is the circumference of the base, h is the height of the cylinder, and r is the radius of the base. Now the total area of a cylinder is the sum of the cylinder's lateral area and the area of the two bases. So don't forget about both of them, please. All right, cone. A cone resembles a pyramid, but its base is a circle instead of a polygon, like in the case of a pyramid. Now, in a pyramid, the slant height and the lateral edge are different, but in a cone, they're the same thing. So we're just going to refer to it as the slant height. So here we would have our cone with our radius, and that would be the slant height right there. All right, and that brings us to Theorem 114, which states that the lateral area of a cone is equal to 1/2 the product of the slant height and the circumference of the base. Or, and now notice we used pi r because circumference is 2 pi r, and half the circumference is just pi r. All right, where c is the circumference of the base, l is the slant height, and r is the radius. Total area, that's the sum of the lateral area and the area of the base. Only one base, so only one you have to worry about. All right, and last is sphere. Now a sphere, special figure, special case, has its own special formula. Isn't that special? So, because a sphere doesn't have any lateral edges, no lateral area, just surface area, so no bases either. All right, so that the formula we have is in the form of a postulate, which the total area of a sphere is 4 times pi times r squared, where r, of course, is the sphere's radius. So don't answer any question that says, what's the lateral area of a sphere? Just put a big question mark. All right. It's a trick question is what I'm getting at. So let's look at an example. Jimmy Joe Bob is planning to cover the lateral surface area of a large cylindrical candle can. What the heck's a candle can? With decorative fabric for a theme party. The candle has a diameter of 6 inches and a height of 18 inches. How much fabric does he need? Well, we'll just use our lateral area of a cylinder. Okay, that's going to give us, that's the circumference times h, or just 2 pi r h. All right. So now keep in mind, he's just trying to cover the lateral surface area. So read these problems carefully, please. All right, so we're going to do 2 times pi. All right, the 2 times pi, that's pretty common. That's standard right there. So we're going to keep that. The 3, if you didn't know where we got that, that's the 6 inches, but that's the diameter they give you. So we've got to cut that in half, remember, because the diameter, half of the diameter is the radius. So that right there came from there. And then the height, they gave you right there. So the height's 18. All right, so you plug all that into your fancy little calculator, and you come up with 339.3 inches of fabric. Dang, that's a lot of fabric there. Yeehaw! All right, enough of that. So example 2, we need to find the lateral area, and we need to find the total surface area. So let's start. Whoa, hey, I just gave you all the answers right there. What's going on? All right. So since my animations didn't work, let's go through this step by step. So we use our formula to find the lateral area first, which is half the circumference times the length. So pi r l, because they don't give us the circumference. So pi times 9, which is the radius, 15, which is the slant height, which gives you 135 pi, or 424.11. All right, if we're rounding to the nearest hundredth. So that would be the answer to the first part. The total surface area, we take this and we're going to add it to the area of the base. So we need to find the area of the base. It's pretty simple. It's a circle, so just pi r squared. So pi times 9 squared, which is just 81 pi, or 254.47. So your total area, when you add this and this, would be 216 pi, or if they ask for it in decimal form, 424.11 plus 254.47, which gives you 678.58. Pretty straightforward, right? So those are two examples. Make sure you know those examples. Hint, hint. All right. So next we have volumes of prisms and cylinders. So the last 3 sections of this are going to be volume. Yay! All right. So only, 3 more videos after this? So your next one will be coming soon. All right. Have a good one.